It all begins with something beautifully simple: a single drop of water. This droplet holds the same H2O that fills our oceans and nourishes life. But under immense pressure, water transforms into something truly alien. We're about to witness this transformation, a journey into a world of extreme physics. In liquid water, molecules tumble and slide in a chaotic dance. Normally, cooling locks them into the familiar hexagonal ice that floats in your drink. But we're going to squeeze this water instead. We'll apply a force so immense the molecules arrange in ways never seen on Earth's surface. The result is Ice VII, a form of ice that isn't cold. Ice VII challenges our basic definitions and reveals the universe's strangeness, all from a humble drop of water, a window into the heart of distant worlds. Welcome to the world of Ice VII. To create this strange new world, we need a very special tool, the diamond anvil cell. At its heart are two flawless, brilliant-cut diamonds, chosen for their incredible strength. Diamond is the hardest known natural material, able to withstand pressures that would destroy almost anything else. The diamonds are mounted opposite each other, their tips creating a minuscule chamber. A thin steel gasket holds a single drop of water in place. Dr. Eris Thorne carefully turns the screws, pushing the diamonds together. With each turn, the pressure inside soars, reaching 1,000,000 atmospheres. The force is focused onto the tiny tips, squeezing the water molecules closer than ever before. The water crystallizes, not into familiar ice but into something new, Ice VII. This tiny device creates conditions found deep within planets. The diamond anvil cell is our portal to the universe's hidden extremes. And it all starts with a single drop of water. What does this new ice look like at the molecular level? Shrink yourself to the size of an atom and you'd see a structure of breathtaking strangeness. Normal ice has an open hexagonal lattice, full of empty space, why it floats. But Ice VII is a monument to molecular packing, forged in the crucible of extreme pressure. Its structure is a body-centered cubic lattice, actually two interpenetrating lattices. Imagine two perfectly ordered grids of water molecules, sliding through each other like ghosts. They occupy the same space, not bonded but held together by immense external pressure. This dual network structure is the key to its incredible density. The molecules of one lattice fit perfectly within the open spaces of the other. If you release the pressure, the lattices fly apart and the structure vanishes. Even more remarkable, the hydrogen atoms within are disordered, constantly shifting and jiggling. The oxygen atoms form a perfect crystal, but the hydrogens exist in a state of fluid motion. Ice VII is a solid with a hidden, liquid-like chaos inside. It's a state of matter entirely dependent on its extreme environment. This is the unseen architecture of Ice VII. Let's delve deeper into this strange duality. The two interlocking lattices of Ice VII are alive with motion, constantly vibrating and shifting. Each molecule in one lattice is surrounded by neighbors from the other, intimately close yet fundamentally separate. They don't share electrons or form chemical bonds, only pressure holds them together. This arrangement leads to fascinating physics. The lattices can move relative to each other, creating unique vibrational signatures. Scientists shine lasers through the diamond windows and measure how the light scatters, mapping these vibrations. The frequency reveals the strength of the forces and how tightly the crystal is squeezed. It's like listening to the music of the crystal, deciphering the laws of this alien world. The proton disorder adds complexity. Hydrogen atoms jump between positions, reorienting water molecules. This constant jumping makes Ice VII a poor electrical conductor, but gives it unique properties. It's a solid crystal with a perpetually shifting internal configuration. The dance of the two lattices is not just a curiosity, it's a window into the forces that shape matter under pressure. Ice VII is a masterpiece of nature's engineering. Ice VII isn't just a laboratory curiosity. The universe is full of extremes, and the conditions needed to form Ice VII are found in many places beyond Earth. We believe it exists in abundance within the interiors of icy moons and distant planets. On worlds like Europa, beneath a thick crust of normal ice and a vast ocean, the pressure deep below would compress water into high-pressure phases. Go deeper and you enter the realm of Ice VII, a planetary mantle of hot, dense ice. This has profound implications for understanding these worlds, affecting heat flow, volcanism, and the chemistry of subsurface oceans. Understanding Ice VII is crucial to knowing whether these hidden oceans could harbor life. On Earth, Ice VII has been discovered as tiny inclusions inside natural diamonds formed deep within the mantle. Occasionally, a pocket of water gets trapped as the diamond crystallizes, preserving Ice VII as a messenger from the deep Earth. These diamonds act as perfect pressure vessels, carrying samples from hundreds of kilometers below. Ice VII connects the mysteries of distant worlds to the hidden depths of our own planet. The discovery of natural Ice VII inside diamonds was a monumental moment for geology. These diamonds are time capsules carrying pristine samples from the deep mantle. Tiny inclusions of Ice VII provided the first direct proof that liquid water exists deep within the Earth. This water, trapped within minerals, impacts plate tectonics and the formation of magma. Scientists use lasers to analyze these inclusions, confirming Ice VII's identity without breaking the diamond. This non-destructive archaeology reveals the pressure and composition of material from hundreds of kilometers beneath our feet. The strange physics of Ice VII's interlocking networks influences the behavior of our planet's mantle. It helps us understand how water is transported and stored deep within the Earth. The story of Ice VII is a tale told by the faintest echoes from an impossibly deep and hidden place. Back in the lab, Dr. Thorne probes the secrets of his newly created ice. The diamond anvil cell is mounted on a powerful microscope connected to sensors and spectrometers. He uses lasers to measure its vibrations, the symphony of molecular motion. Raman spectroscopy is his window into the soul of the crystal. A thin laser beam passes through the Ice VII sample, and a detector collects the light. Most light passes through, but a tiny fraction interacts with vibrating molecules, shifting in energy. By measuring these shifts, Dr. Thorne builds a complete picture of the crystal's vibrational modes. The resulting spectrum is a fingerprint of the material, each peak a specific molecular dance. As he increases the pressure, the peaks shift to higher frequencies. The vibrations get faster. Squeezing the atoms closer makes the springs connecting them stiffer. By tracking these shifts, he maps how the material behaves under compression. He is writing the rule book for matter in a world governed by pressure, not temperature. Why go to all this trouble? Understanding materials like Ice VII is fundamental to some of the biggest questions in science. It's about understanding our planet, the formation of other worlds, and the universal laws that govern matter. In planetary science, Ice VII's properties are essential for modeling icy moons and exoplanets. For geologists, it links to the Earth's deep water cycle, revolutionizing our understanding of plate tectonics and volcanism. Studying Ice VII reveals new phenomena and forces us to refine our models of chemical bonding and crystal structure. Each experiment adds another piece to the grand puzzle of the universe. It's a journey of pure discovery, driven by the desire to understand. Ice VII is a key to unlocking the secrets of worlds near and far. Dr. Thorne has gathered all the data he needs. The experiment is a success. Normally, he would release the pressure slowly, letting the crystal relax back to liquid water. But tonight, he decides to try something different: a quench decompression. With a sharp twist, the pressure drops from over 20,000 atmospheres to 1 in an instant. For the Ice VII, it's a cataclysm. The two interlocking lattices, no longer constrained, fly apart with explosive violence. The crystal structure disintegrates in a microsecond. The sudden release of energy is so immense that the sample doesn't just melt, it detonates. A tiny shock wave erupts, a sharp crack echoing through the lab. The metal gasket is warped and blackened, but the diamonds are unharmed. On the screen, the perfect crystal is gone, replaced by a fizzing droplet of water. The experiment is over. The hidden gem of the universe has returned to a simple drop of water, its extraordinary existence ending with a bang.